One, two, three. I didn't know the mic was off. We're back. We're smoking. And we got nothing to fucking do in the comment. Stuck hours, bro. We're gonna get into the conspiracy. Woo! Swirling, swirling.
Hi, this is Dark Journalist. Today I have the exciting Part 2 episode with Oxford scholar Dr. Joseph P. Farrell on CERN and dimensional doorways. Now, Dr. Farrell believes that the CERN Hadron Collider experiments are a cover for a much larger covert weapons operation program. Now, in Part 1, we examined the links between Farrell's Giza Death Star book series and the idea that CERN may be creating a wonder weapon for the 21st century. In this special episode, we'll drill down on the strange nature of the experiments at CERN and the Strangelets controversy that may explain the heightened security around this mysterious project. Is CERN attempting to open the door to another reality? Here we go. Dr. Joseph Farrell, CERN Strangelets, Dimensional Doorways. If we're dealing with a machine that could cause planetary resonance effects very, very secretly, then immediately you've got a military possibility here. If you can generate planetary effects in specific regions with this machine through resonance or what have you, or on other planets or in the sun, do you think they're going to release the information publicly? You know, the speed at which we're acquiring new public technology represents only a tiny fraction of what's available and the incredible advances that have been made in covert circles. If there are indeed breakaway elements inside the national security state working with global corporations on technology that is so far above laptops and smartphones that it's beyond absurd, then on the few occasions where their operations must be run in the open to a certain degree, we must be ready to seize the opportunity to not fall for the official story and to dig a little deeper. Are the CERN Hadron Collider experiments really define the holy grail of physics or something else? Let's go ask Dr. Joseph Farrell.
Dark Journalist. Go for truth in 2017. The deepest questions, the biggest secrets, the darkest mysteries. Dark Journalist. Go for truth. With top guests like Graham Hancock.
Graham, how do we as a society escape the grip of the deep state in the 21st century?
Rather than spending trillions of dollars every year on building up our armies and our weapons of mass destruction and creating a climate of hatred and fear and suspicion, we should be uniting as a human race.
Catherine Austin-Fitz.
Catherine, what is the issue that's holding us back and destroying prosperity?
We have a system which has got a negative return on investment. It's killing human productivity, and where it's going is inhuman.
Linda Moulton Howe.
Linda, you've been fighting against secrecy your whole life. How are we doing in this battle?
There is a kind of energy and synergy that you and I have because we are both trying so hard in so many facets to get to the bottom of what is the truth.
Dark Journalist. Go for truth. Visit darkjournalist.com and subscribe now for a special winter discount available for just $39 for 1 full year. You'll receive exclusive member benefits, including access to the complete high-quality audio archives to stream or download at your convenience, and subscriber-only content, including bonus show material. Sign up for a free newsletter to stay updated on the latest shows. Dark Journalist. This is the year. Now is the time.
You know, we need dark journalists, so just keep doing what you're doing.
Join us now and go for truth.
Well, hello everyone. We're going to get right into this powerful Part 2 episode with Dr. Joseph Farrell on CERN and the very unusual aspects surrounding its Hadron Collider experiments. Now, it would be nice to just hope that somewhere out there we had these humanitarian institutions raising the bar to serve the world with their discoveries. And you know, sometimes that's really true. But with CERN, not so much. Ultra secret, ultra expensive, $6 billion budget, and ultra dangerous, according to Dr. Farrell, with the media trying to brainwash the public with this term fake news to try and salvage some little power they could have. Let me take this opportunity to remind you to visit darkjournalist.com to sign up for our newsletter so you don't miss any of the exciting shows we have coming up for you. Joseph, it's great to have you back for Part 2 on CERN. Now, I want to start Part 2 with a little background on this unusual technology. Now, there are other particle accelerators out there.
Yes.
They're probably not as extensive as the Hadron Collider, but they are operating.
Right.
So approximately how long have we been utilizing these types of experiments and this type of technology? Did it start back in the 50s, somewhere in there?
Oh, it began actually during World War II, because cyclotrons were used, of course, to verify certain aspects of the theory, and also they were modified to separate isotopes in the strong magnetic fields. So you actually had cyclotrons in Nazi Germany, in the United States, and in Japan, incidentally, that were being used to enrich isotopes. So it began there, and since then, they have grown bigger and bigger and bigger as they have been trying to probe smaller and smaller aspects of particle physics. In other words, now you're not even dealing really with protons, you're dealing with the quarks that make them up.
Right. And just real quick, can you explain what a quark is?
You'd have to familiarize yourself with the theory of Murray-Gell-Mann. Quarks are an entirely mathematical, when you look at it, an entirely mathematical thing in order to explain the spin of different particles. And finally, they came to the conclusion, well, particles are made up of other particles, and on we go. We're back with Thomas Aquinas and the argument of infinite regression. In other words, religion again.
Right. Yeah.
So we're doing metaphysics with equations. But anyway, that's where it's all coming from. So you have to make bigger and bigger colliders to probe smaller and smaller things at higher and higher energies to reproduce the effects of earlier periods right after the Big Bang. That's essentially what's been going on. You're in kind of a collider race. But like I say, when you start building magnetic fields that powerful, you're going to start getting other effects that have nothing to do with particles.
Interesting. Now, what are some of the core aspects that will give us an opportunity to see, the hidden side of how the Hadron Collider is doing these experiments, in addition to what they tell us is the official reason? What would you like people to focus on?
Final thing that I want for people to zero in on is this idea that you have the Large Hadron Collider, a circular collider that has counter-rotating beams of protons. Okay, now the counter-rotation here already should ring a bell. Okay.
Right, and that's the Nazi Bell project you're referring to there, which was an advanced physics project they were working on that just disappeared at the end of the war.
Right. And then above this, you've got the proton synchrotron, which is the last stage of acceleration of the proton stream that's injecting the protons into the Large Hadron Collider. All right. The proton synchrotron is a smaller circular accelerator. Like I said, if you run an axis of rotation through the center of the Large Hadron Collider, then the proton synchrotron is sitting off of that axis rotation. And in fact, if you were to bring the proton synchrotron down to the same plane of the Large Hadron Collider, the proton synchrotron is going to sit on the edge of the collider. So in other words, you've got another rotating system canted off of the Large Hadron Collider with its own strong magnetic fields used to accelerate all of this. And that's going to introduce, in my thinking, a localized precessional wobble. Okay? So in other words, the physics of the machine, they'll tell you it's all about particle acceleration, But the hidden aspect of this could be a torsion machine. Think Richard Hoagland here. It could be a torsion machine with very different sorts of physical effects than they're advertising.
Okay.
And there you have the possibility for a real secret project. And you're embedding all of this, as I say, in rock in a nonlinear medium where immensely strong magnetic fields. What happens to rock? Well, rock, particularly if it's crystal-bearing rock, has what are called crystals under stress give off packets of sound called phonons, just like photons. All right, when they're under stress. The interesting thing here is if you look at the actual cameras, so to speak, the detectors, the Atlas detector, the CMS detector, these things have large crystals, lead quartz crystals, and other extremely exotic things that have been put into these detectors to detect and photograph, so to speak, the particle collisions as they're moving through these crystals. Okay, so in other words, you've got very deliberately designed nonlinear medium crystals that are reacting to all of this stuff. So bottom line here, Daniel, the way I'm looking at CERN, you've got the public story. This is all about particle physics. But when you stop and look at the machine itself, you've got a torsion machine, you've got a hyperdimensional machine, and now they're actually talking, publicly admitting, yeah, we're also looking for higher dimensions. And every now and then there will be a story, well, we may have found evidence of that. Oh, really? Well, stop and think about what the machine's doing. It's counter-rotating, that's torsion. It's got another machine on top of it, canted off the axis of rotation for precessional wobble. You've got here a machine that can mimic planetary effects and therefore possibly be in resonance with them or create them. So yeah, I think there's a hidden, esoteric, occult project, and they've hinted at this in the logo itself.
Yes, absolutely. Well, you've mentioned that there's a kind of theme or practice which goes back to some of the work that the Nazi general Hans Kammler and his staff and his secret work on the Bell, of course.
Yeah.
And it was the idea of developing super secret projects right in public view.
Yeah.
Now, CERN certainly seems to follow this pattern with these secret experiments with a very well-known scientific project that's out in the open.
Yeah, it fits the bill perfectly.
It really seems to.
It fits the bill perfectly because, again, people don't realize that in building this machine, they had to come up and literally invent technologies that they didn't have in order to make this machine work, even for the particle physics story. These crystals, little square crystals, lead quartz crystals, and other very exotic things that are extremely expensive to engineer. This thing ran in the billions of dollars.
Right.
And then on top of this, they had to invent a computer technology to be able to handle the massive amounts of data that this thing was generating and separate the signal from the noise. So in other words, again, we're going back to the idea that the computers are making the selection of the data for the scientists to look at.
Mm-hmm.
So it becomes possible, in my thinking, particularly if you grant the fact that you're dealing with a hyperdimensional machine. No physicist, in my thinking, worth their salt would be able to look at that and say, we better plan for the possibility that this thing might have effects that none of us have anticipated. Just look at it. Strong magnetic fields and counter rotation, torsion, and so on and so forth. We better have data selection filters in the computer program to pull anything like that we need to pay attention to. And trust me, that kind of data, since it's so out of the mainstream of public consumption physics, so to speak, by the nature of the case, that data is going to be kept secret and withheld from the public and only released very sparingly. And the other thing that permits, again, if we're dealing with a machine that could cause planetary resonance effects, then immediately you've got a military possibility here. Because if you can generate planetary effects in specific regions with this machine through resonance or what have you, or on other planets or in the sun, do you think they're going to release the information publicly? No. What they're going to do is they're going to set up data correlation experiments, as I suggested, and start investigating this stuff very, very secretly.
So on one hand, they're studying these unusual effects that are taking place, and on the other, they have this public face of finding the magical moment right after the Big Bang. And they set all of this up publicly, of course, to find the God particle. Now, I know they claim that they have it, and that's another whole different avenue to go down. But here's my question. With all of the research that you've done on the Nazi bell, how it disappeared, how the scientists who worked on it were killed, and, we've done a few episodes on this together already, but now you're pointing out some similarities between CERN and what we know about the bell. My question is, do you think with these Nazi ties, with this trail, do you think that the CERN Hadron Collider could be a stage of the Nazi Bell Project, or could be the Bell Project, or related to it?
Yeah, I do think that there is a connection to the thinking of Conler and the bell, because again, you've got counter rotation. You've got something that clearly, when it was turned on, caused an effect that they may not have expected, namely levitation. So let's go back to what happened at CERN when they first turned it on. Remember?
Yes.
Remember what happened? They shut it down immediately.
Right.
And they said, oh, well, one of the coolant tanks for these big magnets in the Hadron Collider was pierced, and it began to heat up, so we had to shut it down. Okay. Why, when you turn on a machine like this, does the coolant tank rupture? And I suspect that what happened was, when they turned it on, they got some sort of effect.
Interesting. Okay, so let's get a little more specific about the effects that you think happened. Do you think that it levitated the way the bell is reported to have levitated? Is that the idea?
When they turned it on, I suspect that the whole thing probably began to pull out of its moorings, so to speak, that they were getting a gigantic torsion effect that they were not anticipating. And we shut it down and had to go in and redo some things, reconfigure the machine, and then turn it on again. And they invented the explanation, well, there was a rupture in the coolant tank. Why was it ruptured? That's my question.
So you think it may have actually been levitating the first time they turned it on?
It might have been starting to pull out of its moorings.
Yeah.
Or to cause some other localized effect that they had not anticipated. So, yeah, I do think that we haven't been given the full story here. Absolutely.
Well, this is fascinating, and because of the excessive secrecy, we can't get the details of what happened. So, if I filed a request, or if some country's scientists objected to what they were up to, forget it.
Tough. Exactly.
So they can stonewall forever, pretty much, about their experiments, because there's no process available, even legally or diplomatically, to get information. So it makes it hard to call them out on their activities. Let's suppose a nearby country started experiencing earthquakes out of the blue, just hypothetically. And as a result, that's a result of the research that they were doing. There's still no way for them to address it, because CERN is a sovereign entity unto itself.
Bingo. This is the problem. CERN is a sovereign entity. It is kind of like the physics equivalent of the Bank of International Settlements. It has the authority on its own to take out loans and stuff like this. It is in the charter that it has a quasi-sovereign status. So when they brought lawsuits in Germany and the United States to prevent it from being shut down, the lawsuits were dismissed because the people bringing the lawsuits had no standing, and the courts acknowledged that they had no jurisdiction over CERN. So what does that tell you? Well, it tells you that CERN's a sovereign entity. You cannot bring a lawsuit against it because it is sovereign. And it has so many countries involved. It is the physics equivalent, the cosmological equivalent of the Bank of International Settlements. And that right there should give people pause. Because why would you need that sovereign status if this project is about open science? Mm-hmm. The reality is sovereign status should tell you that there is a secretiveness to this whole project, that it is not entirely about what they're telling us it's about. So in other words, again, the particle physics thing is for public consumption. You've got a planetary sized torsion machine that I think is the real project here. And let's not forget that one of the movers and shakers in helping establish it was this Nazi lawyer by the name of Walter Hallstein,
right,
who was, an advisor to Konrad Adenauer, who helped write the charter that sets up CERN. That you have this influence behind it, and again, to my mind, this is not coincidental. The fact that you've got this sovereign status and that you've got this kind of physics conception involved and embodied in the machine itself tells me that this is about much more than particle physics. It is a secret project.
Well, you clearly have shown a post-war fascist direct link to CERN, and that's documented.
Yes.
So it's not even like we need to theorize on that here. We also know that the Nazis were obsessed with just this kind of project. They wanted the ultimate wonder weapon to dominate the planet.
Absolutely.
But in another episode, we went into John J. McCloy, who had a strong hand in getting CERN off the ground. But he was made High Commissioner of Germany after World War II. And then later, he was on the Warren Commission that whitewashed the Kennedy assassination findings.
Right.
So, very strange connections all around there. So clearly, we have reason to be suspect of CERN.
Enter the Large Hadron Collider.
According to the Guinness Book of World Records, the Large Hadron Collider is the biggest machine on the planet.
This thing is huge. It's a 27-kilometer underground ring located at a CERN facility near Geneva, Switzerland.
The reason the Large Hadron Collider is so large is because it has one task: to destroy the smallest particles possible so we can better understand how they work.
The LHC is a really big particle accelerator. Basically, it's a bunch of magnets strung together that accelerate subatomic particles to near light speed, so we can literally smash them together and see what they break up into, so that we understand what the fundamental building blocks of those particles are.
The protons and electrons that the Large Hadron Collider work with are so tiny that the task of making them collide is akin to firing two needles 10 kilometers apart with such precision that they meet halfway. And how the Large Hadron Collider does this is incredible.
The LHC needs a really high vacuum environment so the subatomic particles don't interact with matter. If the subatomic particles were allowed to interact with matter, they'd be annihilated and lost. So within the LHC ring, there's a tube that is kept at very high vacuum that the particles travel in. Subatomic particles can be accelerated in rings like the LHC or by linear accelerators. In a ring. And linear accelerators really help us to get the particles up to speed before we inject them into a ring. The LHC has two linear accelerators, LINX3 and LINX4, which produce the particles and inject them into the large LHC ring.
The technologies we develop here at CERN, they do change the world. We understand a lot, but there are really big questions that we don't know the answer to. Big questions like dark matter. Is the Higgs boson a fundamental particle? Does the Higgs boson interact with the dark matter? At some point, we are going to find answers to some of these really, really big questions. And the only way you can do that is with high-energy colliders. We are going to break the standard model that we have. We are going to find a chink in its armor.
Mark Thompson, you are the new Director General at CERN. Thank you so much for joining New Scientists today. There's a bit of background noise today because we are in SM18 with this amazing machine behind us. Can you explain a bit about the room we're in right now?
Yeah, so it's great to have a chance to speak to you. So What you see next to me is a test string of the high luminosity LHC magnets. So come this summer, we're switching off the LHC for a period of 4 years to install this remarkable technology in place just around where the experiments are. This will give us a machine that's 10 times brighter than the Large Hadron Collider, 10 times more data. So it really is an opportunity to explore the universe in a way we haven't done before. This technology here didn't exist when we built the LHC. And actually what we're doing is we're testing it on the surface, because when you go underground, the tunnel is actually quite narrow. So it's much easier to do tests up on the surface. So very, very advanced technology, very exciting, big step forward.
And just to give some context about where we are, outside this room, we're surrounded by the Swiss and French Alps. Underneath us, there's an enormous 27-kilometre ring that makes up the main collider at CERN, the LHC. There's a lot of misconception maybe from the public. It seems quite secretive what's going on here. We had to get through a lot of security to kind of get in here. Can you just explain what is the point of the LHC, what is the point of CERN, and kind of what actually happens here?
The world scientific community, particularly in Europe, have come together at CERN basically to explore the universe, to understand the fundamental nature of the universe. That's CERN's mission. It's as simple as that. We want to understand how the universe works. CERN is the world's biggest particle physics laboratory. The Large Hadron Collider is the world's biggest collider, 27 kilometers in circumference. It's about 80 meters below where we are now. And what we do is we accelerate protons in 2 different directions around the ring. So we start with a tiny bottle of hydrogen, and we put those individual, basically protons, well actually then we attach a charge to them, that's not quite the same. We put them in a small linear accelerator to accelerate them up to a not very high energy. Then we put them into a small circular accelerator called the PS. Then we put them into a bigger circular accelerator to get them up to higher energy. And all the time we're increasing the energy of these protons. And then we put them in the Large Hadron Collider. And we have these big blue magnets that steer them around the ring. So they keep them going in the circle. And they have to be big and powerful because we're accelerating these particles to 99.9999991% of the speed of light. So you have to have strong magnets to keep them on that circle. And every time they go around, we give them a little kick with kind of what we call radio frequency accelerations. And that's how we accelerate them up to these very, very high energies. So you've got one ring of protons going this way around, one going this way around, and then as they come towards the experiments, they're circulating in the ring about that far apart. We then push them together, bring them to a tiny point, and that's when you get this massive collisions, and that's what we photograph, those collisions. And we can figure out from those images what happened quantum mechanically when these protons collided. And that's how we try and understand how the universe really works at a fundamental level. Certainly in our underground facilities, we can't just let people wander down there. Well, you could even see here, there's a lot of liquid helium, there's a lot of high power. But in terms of our site, we're actually quite open. We have the Science Gateway, which I would recommend to everyone to visit if you get the chance. It's the #1 tourist attraction in Geneva. A Science Gateway, a science exhibition being the #1 tourist attraction is an amazing thing. But it's all about the science. That's what we're here to do.
And now you're the Director General of the entire organisation. I was reading that you were the first in your family to go to university, and as a teenager you actually read about CERN. Can you tell me that story a little bit about when you first heard about this and the kind of the journey you took to get here?
I'm not quite sure when it was. It was either when I was 13 or 14. I read a popular textbook, and I'm still searching for it. It must be somewhere at home in Cambridge, or my former home, but I haven't found it. And I read the book, and I was kind of fascinated by the subject. How does the universe work? But I actually found it quite frustrating because the book didn't give enough information. At that point, I just wanted to know more. And that really, I think, set me in that direction. I wanted to be a particle physicist from a very young age. My family was very non-academic, south coast of England, but I was lucky enough to be good at mathematics, quite good at physics as well, which helped. And then obviously really interested in science, really inspired and passionate about science. Then I went to Oxford to study physics, and, well, here I am now.
CERN has been here for a really long time, been here for decades, since you were an undergraduate. When you think about what has changed since you were first learning about particle physics to where we are now, what are the biggest things about the universe that we've actually found out since CERN has been operating?
When I first read about CERN, we hadn't yet discovered the W bosons. We have
The Joe Rogan Experience.
Part of the reason why I wanted to write this book is it's very much like, another thing I do is go around and talk about science and religion. And I'm an atheist myself, so I say that, science leads us to not believe in God. And I talk about this to very different audiences, churches and things like that sometimes.
How's that go?
Well, it depends very much on the age of the person in the audience is the thing. Older people, they've made up their minds. They're not going to change. But young people, even a very, very, very religious young people, are fascinated by what I have to say. It's not that they change their mind right away, but it's like, I've never heard someone put it that way before, right? And maybe they do change their mind later, maybe not, but at least they've heard a perspective that they were not exposed to earlier. I think the same thing is true with quantum mechanics. There's a buttload of books about quantum mechanics on the market. There's no shortage of books about quantum mechanics, but they're mostly with this spirit of, isn't this bizarre? Isn't this weird? We'll never understand it. And I think that many, many people who grew up to be physicists, this is what they're doing when they're 12 years old. They're reading these books, right? And so I wanted to write a book which said, actually, we could maybe understand this if we just tried. It's not ineffably mysterious. Let's be embarrassed that the field of physics has not put its effort into it and make an effort here. And so maybe so that's what my most ambitious hope for a book like this is, that 20 years from now, there'll be a flood of young physicists who think this is really interesting.
Yeah, well, the number, what would you estimate it would be currently? How many people do you think?
Yeah, worldwide? It's certainly of order 100.
That's it?
I think so, yeah. When we have conferences, there's often 12 people there or 20 people.
Holy shit.
Maybe there's more because I haven't met them all, but it always depends on how you draw the boundaries also. Whereas, there's thousands or tens of thousands of people in most subfields of physics. So, why would you go into the subfield where there's no money or promotion chances? It's tough.
Yeah,
that's why you become philosopher.
Yes, but still, that's stunning when you hear that it's somewhere around 100.
Yeah, we have, here in California, we have CQUIN, the California Quantum Interpretation Network, which is a group of us, the people we know in California who care about these issues and who meet to talk about them. And it's 15 people.
Wow.
And again, it depends on where you draw the boundaries and so forth.
But if one of you guys kicks the bucket.
I know, that's why we got to get new blood in there,
Yeah.
But like I said, I do think it's growing, it's expanding, and I'm optimistic. I tend to be optimistic. There is